This video is for VMD 3. We're going to start with here on page 1 with the number 4, which is the first algebra type problem the students will have seen. It reads, the sum of two numbers is 240. One of the things I will ask a student who's asking me for help is, what does sum mean? They need to be able to come up with that is for addition. They should know that based on the word problems they've done in the past. The bigger number is twice as much as the smaller number. So as you can see, we represent the smaller one in a little box there instead of x, because x is really a slightly higher concept than a younger child is capable of. Some children can do it, but most children need to see something physical. So instead of an x, we just put a small box. And we write the word smaller in there, so it represents the smaller number. The bigger number is twice as much, so we need two boxes to represent the bigger one. And since it's a sum, we put the addition in between. Then you can have the student tell you how many smaller boxes are there. I usually say, okay, so how many smaller boxes do we have? And they'll say 3, and then I write 3 with the smaller box. Sometimes I just write an S. Then you can say, okay, so 3 smaller equal 240 as well. So then I say, and I don't even tell them division, I ask, okay, if 3 smaller are 240, what is one smaller box? And usually most children get that it's 80. Some will not understand what operation to do, so you can lead them there and say, okay, what do you think you do? And they may come up with division. They should have done enough word problems like this in HMD where they had to do division, so it wouldn't be so out there. Some may think they are not able to do 240 divided by 3, but they have practiced in HMD and in earlier VMD 1 and 2 how to do, if they know 24 divided by 3, then they know 240 divided by 3. So remind them it's really just 24 divided by 3 with that extra 0. So 8 becomes 80. And that is your answer. Now I'm going to talk about doing the trick with numbers close to 10 or base 10 higher multiplication. This is a Vedic math trick. And I had never seen it before until I was looking through their methods. And while it's not the most useful sometimes, I like it that it changes it up. It's a little different. And it gets the kids to see some of these things as a puzzle. And it shows them how some things can be solved really quickly and easily. So the first thing you have to do is set it up carefully. You put the 12 above the 13, and then 12 is 2 away from 10, so you put a positive 2 over to the right because it's 2 higher than 10. And then you put 13 is 3 away from 10, so you put a 3 to the right of the 13 underneath the 2, and it's a positive 3 because it's 3 above 10. And then you're going to multiply the right column, 2 times 3, and then you're going to choose either diagonal to use, it doesn't matter because they'll result in the same thing. To get the other part of the number, you can either do 13 and 2, and you add these. You can see that's going to add to 15. Or you can choose to use the other diagonal, 12 with the 3, and you can see that will also add to 15. So you put the 15 down there, and then you just put all the numbers together. So your final answer is 156. You do not need to add or subtract any place value spots here. There will be times when if it's more than one digit, when you're multiplying the right column, you'll have to carry over. Or later on, you'll have to create another one, but not for this problem. Now we're moving on to VMD 3, page 5. We'll start with number 4. That's the algebra problem. It's the same setup as the one on page 1, so you can refer back to that one. But the sum of two numbers is 150, so ask the child, what does sum mean? What are we supposed to do? They should come up with addition. The bigger number is twice as much as the smaller. So lots of times, if they're still having a lot of trouble with this, I set up the original S block, and I say, okay, this represents the smaller number. If this is the smaller, how can I write the bigger number? And either they come up with the double S or I will show them that. You may need to set it up a couple times for them to kind of understand how to set it up. That's the hardest part of these algebra problems. But once you get going with it and they get in the habit, I promise they will catch on and understand. You just have to make sure you keep writing out S block, meaning smaller. Then once you've got it all written out, we say, okay, how many S blocks, how many smaller blocks do we have? And they'll usually very easily come up with 3. Sometimes they say 2 because they're only looking at the bigger numbers, so make sure that they say 3. And then we say, okay, if 3 S blocks is 150, how much is 1 S block? And again, they can do 150 divided by 3 because that's really just 15 divided by 3 with the extra 0. Then the trickier part is coming up with the bigger number. You need to show them that lots of times I just ask to see if they can figure it out. I say if a smaller number is 50, how much is the bigger? You can go back and reread. The bigger number is twice as much as the smaller one. So if the smaller one's 50, how much is the bigger one? Some children will just be able to come up with 100 off that. Other children need to see it visually. So you can write it out. Since the bigger number was represented by 2 smaller blocks earlier, you could put 2 smaller blocks and say, okay, since each one's 50, we'll put 50 in each one. And what's the total? Well, that's 100. And so that's how you get the bigger number. Lots of times if I'm working with a child and the question only asks for the smaller, I'll still go on and make them find the bigger as well, just to practice while I'm actually working with them. This tends to be the trickier part, to find that bigger number. Okay, we're going to do another trick. This is on VMD 3, page 5, number 5. You can see you have to set it up. These are base 10, meaning numbers close to 10. So if we're trying to do 16 times 11, you put 16 vertically over 11, and then 16 is 6 above 10, so we put a positive 6 over to the right. And then 11 is 1 above 10, so we put a positive 1 over to the right. It does make a difference if it's positive above or negative below 10 or 100, as we'll see later. So make sure you put the positive to keep that in mind. Then we're going to multiply the numbers in the right column. So the 6 times the 1 will be multiplied together to make a 6, of course. And so you just put the 6 under there. Then we can add either diagonal, either 16 plus 1, or we can do 11 plus 6. And so if we did 16 plus 1, we get 17. Of course, we get the same thing if we do 11 plus 6, sorry. And so the answer then is just 176. You don't have to add or subtract any extra place value numbers. Everything is just that simple. All right, and that is how you do those.